Alrighty, so you should have your triangles out, and remember that you should have reflections that look to other. Right, so make sure that you have shared with your neighbor correctly. And wait, no, wait. This is the. Can I borrow one of your yellow ones? I'll give it back. Sorry. Okay, so if you have this would be the same. You see how these are just exactly the same? This is reflections. This is a no.
Okay, we're good.
This is yes. So, there you go. Thank you. Once you're make sure you have the 6 triangles you need. We're all there? Yes? Awesome. So we're going to move this out of the way for a little bit and grab this. And this is going on page 87 when we're done. And because I'm recording, I have to use this program, and it makes the screen jump in. And I'm sorry, all right, so we reviewed 30, 60, 20 triangles the other day. So we know when we go to solve them that to label it, across from 30 is S, the hypotenuse is 2S, and this is S squared root of 3. We all agree with that? I hope so, because that's the way to do it. The answer is yes. I agree with that. Okay, now that's, if we need to solve for a side, but we also need to think about this, how the sides are just related to each other without variables. So what if the hypotenuse of this triangle 1, then what would the length of the short leg be? 1/2. Awesome. And then the length of the long leg would be? Good. Square root of 3 over 2, which is 1/2 times the square root of 3, but then we write it as 3 over 2. So we all agree with that. And just next to each other here, this picture. And we're going to make sure that we got them before we move on so things aren't confusing on the other side. And then on the paper and on the triangles, just so many in that one, and 2 in that one. And then do the same thing inside of these. I just did a 2. Dang it. A 1 and a 2 here. Everybody good with that? Okay, so then we're going to move those and grab your 2 and make them look like these 2 at your right angles and all 4 of those. This thing we did in geometry, the answer to that kind of like the activity, because we've been talking about the school for years, but I knew that this wasn't actually being done in pre-cal. I felt like something y'all needed to see, but now that I can make sure that it does happen in pre-cal, and so it is happening now. But so do much more with it, so it's definitely worth doing it again. All right, so let's move this out of the way, and then let's look at this 45, 45, 90. So we know when we go to solve that we label this L. So if that is the case, then that means that L squared 2 equals 1. And I want to know what a leg is. So the leg is 1 over the square root of 2. Can't leave it like that. So what does that become? Good. Square root of 2 over 2. So then square root of 2 over 2. 2. Everybody with me? And that's your peak triangles are already labeled as for you. Where it's coming from. Your pink triangles, make them reflections of each other like this. And we're going to do the same thing we did for the other ones. Add the right angles in the Roman numeral 1, Roman numeral 2, and do the same thing on the triangles themselves. flip this over and start looking at our unit circle. The unit circle is a very beautiful thing. There's so much going on here. We're going to touch the surface of today. We'll come in much more with it than we can get shoved into one day. But so here's our circle. When you first look at this, and the reason it comes up in geometry is to get the that was the thing that you need to know. Now, using the conversion, but these are just need to learn them and understand all of the stuff. Let's make games of them, whatever you want to do, but it's not anything you have to complete. You go ahead and to practice or do your own thing, whatever you need to practice it. All right, so we're going to start with your green number 1 triangle. Okay, it goes right here in quadrant 1. So you are going to set this down 30 degrees on the center of the circle. The long leg is on the x-axis, which means the vertex at the 60-degree angle should be right on that point, right there on that circle. So once you get it all lined up nice and pretty, you take a little piece of tape, tape it down. Okay, and you're going to have to share the tape. You might want to rip off a few pieces at a time and kind of stick them on the side of the box, the side of the table. But please share nicely. Sharing is caring. And share quickly. Quickly. Yeah, yes. Don't tape all that. Just a piece of tape right here. Thank you for clarifying that. So it's 30 degrees right here. What is 30 degrees in radians? I'll give you a hint. It's right in front of you. Yeah, okay, good. 6. Because I have right there that 30 degrees is pi over 6, right? So this triangle that is now sitting on top of my circle, the hypotenuse of this triangle, the hypotenuse of this triangle is the radius. Okay. This ordered pair for this. Okay. So at this point, if I travel around my circle till it ends up here, it's still 1 unit away from the center because that's the radius, right? But then it has a different coordinate as far as ordered pairs are concerned. What would the x value be here? Square root of 3 over 2. And the y would be 1/2. So let that sink in for a minute. Make sure you understand why. If you're going to plot a point on the coordinate plane, you start at 0, 0, which is right here. You go to the right, whatever the x value is, and you go up, whatever the y value is. So guess what? That's the square root of 3 over 2 for the x and 1/2 for the y. That's where that's coming from, okay? From that little right triangle that's stuck right on your circle, okay? Are we good with that so far? So now we're going to take this triangle and you're going to reflect it down. And then we are going to label, put your right angle on there. This is 30 degrees over here. This is 60 degrees. And so this length right here is the square root of 3 over 2. This is 1/2. The hypotenuse is still 1. Like all the measurements are the same as what they were on the other side. It's just there's no way that it would have been printed correctly if we did it on both sides. And if we labeled before we did this, it would have been like side backwards. So, and 30 is pi 6. Okay, and what? 4. So this is quadrant 4. Now, after you get the label, now as I was labeling, you see how my triangle is kind of moving. It's moved around a little bit. Put it back right where it goes, it's all in the right place. X, it's up there on the x-axis. This vertex goes on this. Move anymore, you reflect it back and forth. It should stay nice and exactly where you have it. You don't need a piece of the way a little bit. It'll be fine. Okay. All right. So when my point ends up over here, if I start at 1, 0, and my point rotates all the way around the circle in a positive manner to get right here, what would that angle measure be that it went through? 330, right? Or 11 pi over 6. You agree with that? This angle right here is 30, or pi over 6. How is that angle related to my 330? What's it called? The reference angle. Reference angle is the shortest way back to the x-axis, right? So for 330 degrees, or 11 pi over 6, this 30 here is my reference angle. Does that make sense to you? So if I know what's going on with 30 degrees, and I know that that's my reference angle here, then I can make 330 or 11 pi over 6 make some sense here. Because when I'm looking at my triangle here now, what is my x value? Square root of 3 over 2. What's the y value? Negative 1/2. Because I'm in the fourth quadrant, right? The values are the same. Right? It's just the signs that are different. So technically the values aren't the same, but you know what I mean. The number itself is the same. It's the sign that's different. Okay? We good with that? Do you see how this 30 degrees being a reference angle? These 2 points are the same. The signs change depending on which quadrant I am in. Everybody okay with that? All right. So now take your other triangle. Place it down with this vertex in the center like so, and make it all line up. Take and tape it down. That 30 degrees is pi over 6. This angle right here on the circle, the angle to get to this point is 55 pi over 6. But pi over 6 is the reference angle. Okay, does that make sense to you? Right, so that here, this ordered pair for where this point is, what's my x value? Negative square root of 3 over 2. And my y value is 1/2. So then we're going to take this and reflect it down and label everything we had. And make sure so once you have it, then put a little piece of tape on there. Roll it back up there. You've known point. You learned that first is positive. So, all right, so let's look at what we have so far. Well, that point. Let's just talk about these other 4 that you wrote down. You just changed the sign. All 4 of those points have 30 degrees. Now, this would have been really cool if we could have like it's the same triangle that you were this way. be kind of hard to do. All right, so with that, if you look at the angles that all have a reference angle, what do those four angles have in common when you just look at the numbers? What do they all have? So pi over 6, 5, 7 pi over 6, 11 pi over 6. At those sixths that you have angles, those are going to be have a reference angle of pi over 6. Four of them gets me, right? I'm 6 pi over 6. I go one more to 7 pi over 6. That's why that is my reference angle right there. Does that make sense to you? All right, so let's put a little green one back down and pick up your pink quadrant 1 triangle. Set it down right over one. 5 degrees is what in pi over 4. Okay, so let's think about that over 4 as well. We know that this is 0, 90 is pi halves, right? So 30 is 90 divided by 3, or it's one. Let's say 30 is 1/3 of 90, right? So pi over 6 is 1/3 of pi halves. 1/3 times pi halves is 6, so it's a third of 90. 90 is pi halves. 45 is half of 90. So half of pi halves is you, and then just halfway each way around in each. Knowing all that, the x value here, 5 degrees or pi fourths, what's the x value? Square 2 over 2. It's okay, that's happened. Square 2 over 2. It's the angles that have the pi's in them, and then the ordered pairs have the square root. Table again. So this is 45, 45. Square root of 2 over 2. Square root of 2 over 2. Hypotenuse is 1. Quadrant am I in? Fourth. And then this is pi 4. Make sure that. And then when I put my little piece of tape on it, I'm basically taping it to the green triangle. It's fine. It all works well in the end. We're still going to be able to reflect both and do them individually, whatever. So my x value here then is square root of 2 over 2, and my y value is negative square root of 2 over. Any questions at this point? All right. So let's take our other people, put him down over here and line him up. This is pi fourths. So basically this is just reflection across the y-axis. And when you reflect in the y-axis, you change the sign on x. And that's exactly what's happening here. I've reflected it in the y-axis. So the point stays the same. All I do is change the sign on x, negative square root of 2 over 2, square root of 2 over 2. Then I'm going to reflect this down. And thank you. He's not here today. Two, 3. All right, so in the second quadrant, I'm at negative square root of 2 over 2, square root of 2 over 2. When I reflect in the x-axis, all I do is change the sign on y. So stays negative square root of 2 over 2, and then negative square root of 2 over 2. Great. Here. Hold it. Yep. Quadrant 1 yellow triangle. Put it down. This is pi over 3. 30 is pi over 6. Because 30 times 2 is 60, right? And if I have pi over 6 and another pi over 3. It's a third. Q is 1/2. Y value is square root of 3 over relabeled here. Now, this is pi thirds. X value is a positive 1/2. Y value is a negative 3 over 2. By now, I kind of get the pattern that's going on there, right? Reflect it back and forth. But so much than what we're seeing right now, we're getting it. So once you've got that one taken care of, go ahead and put your last triangle on there. This is pi thirds. So I'm in the second quadrant. This is negative 1/2. Positive square root of 3 over 2. Hopefully, all triangles are tall enough where they fit, right? And notice I'm not putting any negative numbers on the triangles because these are sides and down and the length. Square root of 3 over 2. All right. Then we are missing a few ordered pairs here. We have this one right here, B, 0, 1. And this one would be 0, negative 1. Okay. All right, so since we have these reference angles, what the ordered pair is here at 7 pi 6, my reference angle, or I'm sorry, I'll make this 4 pi thirds. My reference angle is 60. So all I really have to know is the first. If you understand the reference angles, the is all you know. One of these individually. is when you look at these ordered pairs, well, actually, when you look at all of the ordered pairs except for the quadrantal ones, but all of these that we filled in first, every single one of them is something over 2. Would you agree with that? So they're all over 2. We have to decide, was it over 4? They're all over 2. Okay? Medians, they could be over 3, 4, 6, whatever. But all of these ordered pairs that are special ordered pairs are over 2. Then, when you look at them written out like this, look at the numerators. Let's start with the x values. It goes 1, 2, 3. The y values go 3, 2, 1. And technically, they could all have the numerator because it's the square root of 1. 1 is just ridiculous to write it. Okay? Does that make sense? See how that 1, 2, 3, and 3, 2, 1 goes? If you can picture that first quadrant in your head, you can get the rest of it. But again, you have to learn it. And I'm going to help step you through it, give you different ways to see things, like a little bit each day, so it's not overwhelming. You have to be practicing it along the way when we do this. If you think you're just going to listen in class and not worried about it again, or you're going to wait and memorize it the night before, well, memorizing it all the night before might get you through the quiz, but you won't remember it long term. And our goal is to learn it so that we remember it long term. With that, but you just can't be resistant. Okay? Are we all good so far? Now let's talk about why we even care. Like, why do we even care about these ordered pairs? What does this even mean? Why do I need to know this? So on the top left corner of this, right, sine theta. Now in general, you were finding sine. Sine is what over what? Opposite over hypotenuse. So sine is equal to opposite over hypotenuse, right? So here, what's happening with these? Let's just look at 30. There's nothing special about 30. It could be anything, but the sine is opposite over hypotenuse. On the circle, what that means is the opposite is which value? Well, but not specific for 30, but just in general, what is this value? So what? What goes up and down on the coordinate plane? Y. So the opposite is your y value. Using 30 or 45 or 60, it doesn't matter, right? The opposite is the y value. We that. What's the hypotenuse? The radius. The sine of theta, which is opposite, is y value over the radius every single time. Now, specifically for this circle, what's the length of the radius? 1, because it's a circle, but not all circles we deal with will be unit circles. That's why this part is important. But for us right now, this is y over 1, which means that the sine of theta is y. If I look back over here, sine of 45 is square root 2 over 2. The sine of 60 is square root 3 over 2. You see that? It's just the y value. That's all it is. Okay, now let's go to the bottom left. Cosine is always adjacent over hypotenuse. The adjacent is which value? X value. So x over the hypotenuse, which is the radius. And in this specific case here, the radius is 1, so we can put x over 1, bless you, which means that cosine theta is x. So there's my ordered pair right there, x, y. These ordered pairs that you have, and we'll write it over the corner. It's cosine theta, theta. That is your x, y. It's an order just like x and y are. Cosine comes first. Cosine is your x value, sine is your y value. So right here where the one we can see right now, 300 degrees. The cosine of 300 degrees is 1/2. The sine is negative square root of 3 over 2. Right? Those of you in physics, you know, or 4, or just in MG, MG then. Right? And so you do that, you're getting it from vectors right now? Is that what y'all are doing? Months ago? That's not, but it's coming from vectors or no? Is that when you did mg sine theta, mg cosine theta, maybe? RAM. Yeah, you had like, yes. So it was vectors, or you had little triangles. But that's what it is right here. Look, cosine theta equals x over r. By both sides, x equals r cosine theta. That's what this is. R is 1. So x equals r cosine theta. That's mg cosine theta. Mg sine theta. Your radius, which would be like the hypotenuse of the triangle that you're doing with the ramps or whatever, that's what that is. It's the same thing that you did before. Okay? It all relates together when we get to pictures. We'll make a little more stuff. All right, let's go to the top right. Tangent theta. Tangent is what over what? Opposite over adjacent. Right? Okay. So opposite over adjacent, and your opposite side on the circle is your what? Y. And so I'm going to write tangent theta is equal to y over what's your adjacent? X. Okay. Which also means that tangent theta, okay, so what did we say y was? Yes, it's opposite, but what else is it? Sine. So this is also sine theta over what? Cosine theta. So tangent of theta is sine theta over cosine theta. So what that means for you then, find a piece of paper to write on, is this. Here, this is 30, right? 30 degrees. So the cosine of 30 is the square root of 3 over 2. Sine of 30 is 1/2. So if I want the tangent of 30 degrees, it is the sine over the cosine. So that would be 1/2 over square root of 3 over 2. So what do I do when I divide fractions? I what? Oh, you can't see. I thought somebody was saying canceling. What do we cancel? Can't see. Okay, sorry. When I divide fractions, what do? Flip and multiply. Okay. So get 1/2 times 2 over the square root of 3, right? What happens with the 2's? They cancel out. So I'm left with 1 over the square root of 3. Do I get to leave it like that? No, so it's a square root of 3 over 3. So that's where the tangent of 30 comes from. Okay, does that make sense to you? Now, we'll figure out the tangents. Not right now because it's like a little overload on that, but and there's an easy little pattern to help remember those as well, where you don't have to calculate them every time, but you can. And if it's not a special angle, that's how you can do it. If you have the sine value and the cosine value, you can find the tangent value just by making a fraction out of them. Okay, does that make sense? We need to know this relationship. All right, so a couple last things here. Get your ID badge to go straight edge because I didn't put rulers on your table. And flip all these first quadrant triangles down. And I want you to draw in a angle. It should be there. So we're basically angle there. So this then I want you to take your ID so you can take another line and make it since they're but right. Right. And it'll go through one of your ordered pairs and it's fine. But just draw that in right there. The ray that comes through. And we have a right angle, so we know that really means whether it's good. And we're going to take in this segment here that makes that 30 degrees. So that you get that point right there. Then we're going to make this point, and we're going to name it A. We're going to make this point, we're going to name it B. You did that. Do you see the two overlapping triangles that you have? Triangle. Are they similar angles? Yes. And how do we do that? Okay, they have similar angles. They have the same angles. They have congruent angles. So they are similar by angle. That's important. triangles are similar by angle come up. They share this angle here because they're stacked, right? And then these two angles are the same, so that's your angle that tells you they're similar. Since they're similar, you can make a proportion out of them. Now, look at this side of the bigger triangle. What's the length of this side of the bigger triangle? What's the bottom? 1, right? It's the radius. We already got. So this is 1. So I can proportion. This side, which is the sine theta, over cosine theta, equals AB over 1. You on that? Just proportional triangles. You've been considering triangles forever. Since I'm putting AB over 1, does the over 1 even matter? No. Okay. Which means that I can put sine theta over cosine theta, and that has to equal to AB. You with me on that? So if since sine theta over cosine theta has to equal the length of AB, because it's really AB over 1, right? Just corresponding sides. Well, what does the sine of theta over the cosine of theta equal? Tangent theta. So the length of AB, this is tangent theta. So the length of AB equals tangent theta. So for this particular triangle, cosine is square root of 3 over 2. Sine is 1/2, so that's the lengths of these. Then the length of line segment AB is the square root of 3 over 3, because that's what we found for the tangent. Okay? Now take your ID and take that side of that triangle and extend it down past that point B. And now we've made a line. What kind of line is that? It's a tangent line. Next circle of how many points? 1. That is why a tangent line is called a tangent line. Without all this, that makes no sense early on, right? And it's like tangent lines and trig have nothing to do with each other at all. They totally do, okay? Because the segments that hold the tangent length all live on that tangent line. So if we were to continue this, which we're not, extended this degree line out here, and 45. Okay, is that to you? Is this angle 45? And if I still have a right triangle, what's the angle? This length is 1. What's this? 1. The tangent of 45 is 1. Okay? Then you could keep going, but it wouldn't fit the paper. That's where that comes from. So there's this crazy picture I'm going to show you eventually, I don't know if tomorrow or the next, where like the tangent line and how you find the value of secant and everything with lines here. The secant, how many times do you think it intersects the circle? Twice, because the secant line intersects twice. The tangent line intersects once, and all this come together. Again, this is just the tip of the iceberg as far as the patterns and what else is coming out of here. Full of a lot of information where things are, why you call them what you call them. Oh, I mean, if I give you 2 is knowing your angles and radius. Know, I say, what is 45 in radius? You can tell me. Know your reference angle. If I tell you have 5 pi over 6, you need to be able to tell me what the reference quadrant I'm in. Okay, those sorts of things. Essentially, these ordered pairs, but I'm going to give you some other ways to learn those. I just want you to see them and how it all works together right now. Back to this. This is super important. Go ahead and glue it or tape it in. And the quiz is ready for you to practice however many times and however you want to practice. Okay? The more you practice, the more you just know it and understand it, and it will be good for